Good afternoon, Jan.
Michael, good afternoon.
Yes, 1 hour later.
Yeah, I was there 1 hour ago. Then I saw, okay, I still have a little bit time. But actually, that was quite well because I needed that time.
Ah, okay. Well, good. Glad
Yeah,
to,
not
happy to oblige.
I. No, I need it for programming more, but no. In general, I say being married is a blessing. But if now my children would ask me, Papa, should I marry or not? I would say think twice. So, sometimes,
Yeah, you definitely
yeah.
have to choose well, and yeah, I know that I've chosen well. I believe that you have as well.
In general, yes. In general, yes. But at this moment, it's a little bit more difficult.
Mm.
But okay. Yeah. This evening it will be better.
Yes.
Yeah. Okay. No.
Yeah.
It's
So yeah, I've been spending probably far too much time on the syntax that we talked about last week, and really trying to hone
mm,
that. So yeah, there are a few things that I really should be getting to. Purge is the next big thing, and I really want to get that done. But uh, but yeah, I think that it's just about to a point where it's going to actually be an easier onboarding. So,
mm,
oh, this camera is autofocus crazy. Um,
mm,
but yeah, um, the new syntax, it's more concise as we talked about last time,
mm.
but it also I think does seem a little bit more like what people are used to, with just enough of oh, this is different, that that they might not fall into the trap of just thinking that it's entity framework. Um,
Mhm.
so I don't know, but yeah, and then also it's yeah, it's got some extensibility now, so that you can create your own patterns, and so I think that it can be even more concise, even more um, uh, just the intention that you bring to it, um, and then it'll expand into the specification that is required to implement that intention.
Okay.
So
'Cause I
yeah,
saw a lot of mails coming in from GitHub, uh, even 10 minutes ago.
yeah,
Still last one. Um, but I didn't check the code at all. I still worked a little bit on that combo box, but even that I didn't finish.
hmm,
It was too hectic. Um, but so what exactly did you do on that syntax?
yeah, uh, yeah. Let's. I still haven't started up the Zoom. Should probably go ahead and do
Oh wait,
that.
I
Um, I can also do the Discord share, but let's let's start it this way. No computer audio, and allow multiple share just in case. All right. So there's the screen, and so there is Visual Studio. All right.
meeting.
And I need to make sure that everybody else can see it too.
Yeah.
There we go.
Okay. I can see it.
Okay. All right. Well, to start things off, for this experiment, I have been using the NuGet repository that's hosted by GitHub. So you can see in here I'm using Blog Maui for this. I've got uh, these weird package versions installed. So these are pre-release versions. And if I
Mhm.
go up to, uh, let's see, let's pull this over. All right. Yeah. So I go up here. I've got a NuGet package GitHub action that I can run on any branch. So if I run it on the Michael L. Perry add successors method branch, then this will build and package, and then it's going to assign one of these strange version numbers. So this is a tool called NerdBank GitHub or NerdBank Git version, and so it's going to use the depth of the Git tree, and then the Git commit hash in order to come up with a new version number every time. So I've got that that installed there, and so this then will push it after it packages. It will do a publish to the registry, and it's going to push that to NuGet package github.com/Janaga. So the Janaga organization now has a NuGet package repository.
Michael, why does it add the depth of the tree and not only the commit GUID?
Yeah, good
Commit
question.
GUID is unique, so.
Yes, yeah. So that alone would give you a unique version number, but the tree depth also gives you a monotonically increasing version number. So so it's easier for you to see just at a glance. Okay, this one's newer than this one. But also, if you were using if you did say give me the latest, and it would automatically give you a later version as you did the build.
Okay.
Yeah, that's a pretty nifty little tool. So with that, I am able to so in here in the every time I worked on something, I said, okay, I did a new build. There's the new build. Yeah, I kept track of the things that I wanted to accomplish in this in this build, and then the things that I wanted to try and experiments that I was running. If you want to set up your own, if you want to authenticate to this registry, it's a public registry, so you can use your GitHub personal access token. Here's instructions on how to create one in order to add that as a source, and then you too can try out these experiments. But
Okay.
yeah, I tried various things. So so last time we talked about the relative merits of two different options for successors, and I ended up with the successors of type T syntax. So let's come in here and let's take a look at a view model. So this would be the site list view model. Okay. So here is the currently supported syntax. So I favor the LINQ keyword syntax, the things that look like select statements from SQL, and this new syntax allows you to, if you prefer, use more of the chaining syntax and have that be more concise. But we'll take it one step at a time. So the first part here, we've got facts of type site. So instead of that, we can use user.successors, and that's not immediately available to you. You have to add using Janaga extensions. And I decided to do that so that this successors method wouldn't show up on every single object that you pulled up IntelliSense on. Yeah, and that's because this is an extension method on a generic type, so anything matches. I might be able to restrict that type a little bit and make it just records. I don't know. I'm not even sure if that's a generic constraint. But at any rate, so we've got our successors, and then we do dot of type, and then the generic parameter we are looking for site. And then we've got, starting from the site, we go up to the user is what we are starting from. So that's going to be the site creator.
Mm-hmm.
So with that, we've gone from facts of type site to successors of type site, and we've put this predecessor selector right here, so that means we don't need it to be here anymore. So now we can get rid of that. Oh. So that that has the advantage of making it clear that you always have to join your successors back to the predecessor. That is a non-optional part of this particular of type. There is no variation that doesn't require that predecessor selector. Now it can be a regular predecessor or a collection of predecessors, and we'll see why that's important in a little bit. So that's step one. Now step two, we've got this not facts any. And this is the part that when I pronounce it out loud, I see people staring up the ceiling, trying to parse it in their head. And then I go back and I re-explain the words, and I end up speaking math while I do that. So this is the part where I think that people will get it a little bit more easily because of this new syntax. Mm-hmm. Okay, so we've got a few options. One of those options is to, so I'll keep that here and I'll just type a new where clause. So we'll do user.successors again, but now instead of type, we can use any or no. So the negative is already built in, and it makes it read a little bit better. So no site deleted. And then we put that predecessor selector here. So, it's not the user, it's the site. So that is the equivalent of that part. Mm-hmm. But we have this other part, and unfortunately we've already used this as the predecessor selector. It's no longer a predicate. So this part, it's not, it's not, one-to-one. You can't always convert every expression over to this form. So that's kind of the downside, is that for that convenience, it gives you a particular pattern, a particular way of looking at things that is not always exactly what you want and can't be extended into exactly what you want. But have no fear. There are other options. Okay, so we've got the successors.no as an option there. What we can do is, you know what? This, yeah, I'm trying to think through what are the various options, and this might not be one that has a really clean use case. So let's try out some of the
Michael,
options. Yeah, go ahead.
but could we not make a syntax, because this deleted and not restored is a very common template that we need.
Yes.
So could we not have just a single syntax for that?
Yes, in fact we can. And that's one of those patterns that that I'm that we can now support. So so the patterns would be things that are not built into the library itself, but are things that you can add with extension methods. So we'll do that in just a little bit. So let's, yeah. So that's the successors no. In order to see that a little bit better, we can do it here. So this is going to be from deleted dot successors no site restored, or restored dot deleted. So those two things are equivalent, so we don't need to have that anymore. But yeah, because we need access to deleted here, we can't do the successors no out here, because once we've done this, we've lost our access to deleted. So we can try a few things. Now there is another syntax that I implemented here. Let's go down to this one because I know that this one works exactly with this syntax. So here we have no facts of type site name next, where next prior contains name. So that's the one that I have to read that pattern out. People looking at the ceiling trying to figure out what I'm saying, and instead I can express that like so. So I can yeah, there's a a couple of different ways. So let's first go with what we just talked about here. So we've got site dot successors no site name next prior. So that is the same as that, and this should be allowed. Cannot implicitly convert site name to IEnumerable. Oh, yeah. Name. It can't convert it to an IEnumerable site, but it can convert it to IEnumerable name. So it's doing the proper type checking for you. So yeah, so now already this reads a little bit better. So so there are no name successors next, where next prior points back to the name. So it's still a little bit clunky, but if we use the syntax in both of these places, then watch what happens. So this now becomes, instead of facts of type site name, we've got site successors of type site name. And then in here we have to do the lambda, so we'll call this name dot site. So now we've got that, and so we don't need this anymore. And so that means that now we can take this whole where clause with the no, and we can shrink that all together. And that allows us to do this, dot where no. And in here we have to use the, you have to give it the hint of what the parameter name is. So there's no site name called next, such that next prior relates back to the site. So that replaces that where clause. So starting to get even more concise, even more readable, closer to what people think about. So now that we've got this, the from select isn't doing us any good, so we can shorten this even more. This is just going to be dot select name dot value, and we've gone excuse me, all the way down to the chained syntax.
Mm-hmm.
So yeah, here's an example. It's still sitting here of the full syntax. This is the chained syntax. So this, I find, it gives you all the little places where you can continue to extend things, whereas this takes away some of those extension points, but makes things a little bit more readable, a little bit more concise. This will come in especially handy, like here you've got select new, and so you're referring back to the site, but what if you had other points along the way that you wanted to refer back to? This allows you to name those various points and then use them in the select, versus with the chain syntax, every time you continue the chain, you continue it just from the last point, so you lose all the other labeled points. You have to do some funky stuff with selecting tuples and things in order to get the behavior you want. But it's doable. But yeah, now you've got the choice. So a really interesting thing about this where no, and its opposite where any, is this is implemented with a function that takes an IQueryable and returns an IQueryable. So the source is some IQueryable of some fact or even projection, and then the IQueryable that it returns is of the same kind. So this ends up being a filter for that queryable, and then the parameter that you see is the expression of function. So that's the predecessor selector. So what this does, and when it decompiled it, it did this weird thing where it defined this, but in the actual source code, this is a one-liner. So this under the covers does a source.where and then uses the successors.no syntax that we've seen before. And so that just gives you the long form of what this actually does. And anybody can do this. Anybody can define a function that takes an IQueryable and returns an IQueryable. And what the LINQ expression, what is that thing called? A query provider. The LINQ query provider is going to call this function, let it do its longhand thing, and then that's going to return. That's going to basically build inside of the resulting IQueryable a syntax tree, and then it'll parse that tree. So you could even do some crazy if type logic or anything you need to, as long as you end up returning an IQueryable that's built out of these components. It'll work. It's not actually parsing this code, it's parsing what it produces. So all that to say that we can make up some syntax that is going to implement any pattern we want. So so this is common syntax. So let's go ahead and define an expression or an extension method. I'll just stick it right here for right now. So we'll call this specification extensions. So this is going to be we'll just do this internal right now because nobody needs to see this. A static class, and then we can define a method that returns an IQueryable. And
example, deleted, not restored.
Yeah. Yeah, so it's going to be of something. We'll think of what that is in just a second. So deleted, not restored. And that's going to be generic, so it's going to take something there. For right now, we'll throw not new, not implemented exception. So let's kind of reason through what this needs to be. So we want to use that here. So I want something like the user.successors of type site. I guess I could have just copied this from down below, but site.creator. So now here I want deleted, not restored. And so I'm going to do this syntax here because I probably need to do a type inference on what's coming in. So so this is going to be, we want the site deleted, and that's going to refer back to the site like that. So we've got that lambda, but then we want the restore lambda as well. So site restored, and that's going to be restored.deleted. So that's the syntax that I would like to have. So we're gonna kind of make this wish. Let's say I want that syntax, and then write the contract. So it should be like we've got our T. Yeah, we can call this predecessor, and T delete and T restore. So we're going to have 3 different types. So that'll be the site deleted, site restored. Mm-hmm. So what I want to get back is what I want to get back is so I've already started with the creator. So I've got the sites. Yeah. So what I want to get back is the T predecessor. Yeah. So that's the syntax that I want. Now let's take a look at the. This is going to be an extension of. This will end up being an IQueryable of site. So we will have this IQueryable of site. Well, not site, T predecessor. We'll call that source. So that's the source, and then we've got a couple of lambdas. So those are going to be expression of type func. It's going to be first the delete. So from T delete to T predecessor. So that's going to be the delete selector. And then we're going to have another expression of func. That's going to be T restore. That then selects the T delete. That's the restore selector. So with that, let's see if it's able to, oh yeah, it's missing a close parentheses there. Yeah, so that cleaned things up a bit. So we've got our delete selector, our restore selector. It's done all the type inference that it can. And so it's able to figure out the predecessor being site, the delete and restore, being site delete, site restore. So now we want it to actually do something. So that's going to be this part here. So let's implement that with, I'm going to start with the source. And so now I've got the where clause here, so I'm filtering the where. And that's ultimately going to return an IQueryable of t predecessor. So, since this is a filter, that's the appropriate way to start this. So I'll say s, and then I want to first apply this part. There are not any of the delete with that selector. So we'll do successors dot no delete selector. But I can't do that successors dot no thing, because now I don't have the t delete anymore, because I've used the delete selector. So I have to instead go with the of type, but that's going to be of type t delete. And then, now that I've got that, and it's able to infer the t delete, it's more readable that way. I'll keep it there. But now I've got the delete facts, so I can further, well, I'm going to end up doing a .any on this, and I really want where there are no deletions. But that's not quite all. I want to then further filter this dot where, and that's going to be the deletion. No d dot successors of type t restore with the restore selector dot any. So it's you're able to infer, delete, and restore. I could do this. Simplify the name. Simplify the name. And since this is a helper method, it's kind of tucked away. That wouldn't be too terribly bad, but I don't know. It is a little bit more readable this way, so I'm going to keep it. T restore. So now we have just expressed a pattern, and we've encapsulated that pattern into an extension method that takes an IQueryable and returns an IQueryable. And so I should be able to use that pattern instead of this. Now, of course, because I've got the select new here from site in, I have to do that. Yeah. So now it's happy with that. And I could go one step further. And if I didn't want to do that, then I could say dot select site and then return that. So I could do something like this.
I like the deleted, not restored.
Yep. Just to prove that it works, let me go ahead and run this. So yeah, the the query parser should find anything that that is a method call, and if it's not one of the methods that it already knows about, then it says, well, does it return an IQueryable? If so, I'm going to take all of the IQueryable's parameters, and I'm going to go ahead and compile those, but then I'll pass those in and let you take care of the other parameters and see what it does. So let's give that a run and see if we don't see our site list. There it is. Ba-boom. So we have cleaned things up a bit, made it, implemented a pattern. So yeah, now we can go even further. So one way that we can go further is this whole idea of the site. Well, we can't do that one. So the next thing that we can do is we'll do it down here. We can take these things and make them relations, so they become part of the model now. And that is a way to encode these relations, similar to how you do navigation properties in Entity Framework. So I see somebody on YouTube saying they're joining, so we'll probably see somebody pop in on Discord soon. Telia. I'm looking forward to it. Okay, so let's try to, and so the reason that we can't add this to user is that user belongs to the Java library. That's not code that's in here. But here, the site belongs to us. So I want to have a relation that gives me the site name. So let's go to the site. And here we've got our site fact. What I can do is add another property right here. So it's going to be a public. I'll use this syntax for right now. Relation of type site name. There it is. And we'll call this names, plural. And then using the arrow syntax, we can do relation.define. And so now here I've got a lambda. I've got a couple of options. I'm going to go with just to show what was possible before. I'll go with this option where I pass in facts as a parameter. So this is my fact repository. That allows me to do facts of type and have that kind of syntax. But instead, I'm going to do this syntax right here. And now it's not site, it's this. So that comes from Janaga extensions. Bring that in. And now this gives me, this last select right here, that is selecting a string. I can't do that inside of a relation. I have to get the actual fact. I'll do the selection outside of the relation. And so that gives me a relation called names. It basically wraps, precompiles, it kind of encapsulates that logic into the model. So now when I'm building my view models, I can just simply say names. And all that is over there.
Mm-hmm.
So, in fact, can make it a one-liner. So I still wrap this in an observable so that I can later on say names.onAdded and update the view model with that new name value. So that that part right there is not new, but the part that is new is the fact that this syntax does not use the fact repository. So I don't need this. So now I can change this to a lambda that takes no parameters. It still has to be a lambda. I can't just pass in this part, because that part would get executed, and it's like, I don't know how to do that. But with the lambda, I can say, oh, okay, let me store that off, and then there's a parser that understands that syntax and can figure out what to do.
That's nice.
Yep. So I can imagine showing people you're showing people this syntax right here. So they start off with successors of type, because at that point I'm teaching them, hey, in this system, you've got predecessors, you've got successors. There's your predecessor. You just this right here. There it is. That's the predecessor, and then this is successors. But I first show them that inside of a view model like this. So you've got successors of type. Great. And then I start to show them some of the patterns to to implement the things that they're entities and properties and deleting things, and that brings in some of these things like where no and where any doesn't actually show up very often. It's usually negative existential conditions, but I don't have to use that phrase negative existential condition. I can just say where no, where no site name related back with the prior. So kind of gradually build the syntax up, then get to a point where I'm saying, you know what, you might want to define your own patterns. So in fact, this right here, this could be a pattern as well. So let's take this specification extensions and let's move it someplace. Oh, there's actually a folder called extensions. Let's move it there. Yeah, so maybe we'll want to have an extension that is for mutable properties. So how would we do that? So I would want to basically take this information here about the site name predecessor selector, and then the next predecessor selector, and turn those into parameters. So again, IQueryable, returning IQueryable. So this is, now this one's not a filter. This one you're actually getting the successors of this thing. So I'll have the t predecessor. Well, it's going to return the t successor. So I'll call this mutable of type t predecessor, t successor. So those are the only two types in this one, because the successors have their own successors. So the next is also a successor. And so here we've got, starting with the IQueryable of t predecessor. That's our source. And then I'm going to have an expression of function that goes from the t successor to the t predecessor. So that's going to be the predecessor selector. But then once I've got that, I need another expression that goes from t successor back to another t successor. And that's going to be my prior selector. And so with this, I should be able to say I want the source successors of type t successor. And that is where I use the predecessor selector. But then I furthermore do the dot where no, and I use the prior selector. Let's see, is that going to work? Why does it not like this? Successor, predecessor to successor. Okay, so it can't convert from an expression of function of successor predecessor to expression of function successor IQueryable. Oh! Yeah, I do need this to be... I don't need that one to be an IQueryable. Why is it trying to do IQueryable? IQueryable with t predecessor. That is a strange one. So predecessor selector. Oh, okay. I see why. Okay, because source is coming in as an IQueryable, and the successors is intended to be used on an individual element, not an IQueryable of them. So here it's trying to join that back to the IQueryable source, match that type there, but that's not going to work. So so I have to do something different here. So that means from the source I need to do a select. Select in order to get the predecessor. And then I can get the so we're getting closer. So now I've got the individual predecessors. Let's just give this a name so that it doesn't give us the compiler error and we can actually see what's going on. So the predecessor now is t predecessor because the source was an IQueryable of them. So now I can do the successors of type t successor, get the predecessors. That's good. And then where no prior selector, that should still give me an IQueryable of t successor. Oh, but this is giving me an IQueryable of IQueryable. That's interesting. That's... Let's see, am I closing this too soon? Okay. Yeah, this one's going to take a little bit more thought. So this is telling me that I want to ship these extensions. If I want to teach people that these are patterns that you want to use, then I want to give them these extensions so that I can figure this one out, and then people can continue to use them. Yeah, this one is interesting. So that one returns a, but then that's inside of a select. Select many gets the type right, but is that what we really mean? I'm not certain that's what we really mean. But with that, the type is correct. Yeah, I'm going to have to think about that one. Yeah, well, let's try putting that in place and seeing what happens. So now we should be able to change this syntax from this. Okay. Wait, this is this one. This syntax here. Yeah, names. Yeah, this is where I want to use the mutable. You know what? I don't think this extension is going to fit here because of this. I no longer have my IQueryable to start with. Yeah, this pattern might not lend itself to an extension method because I can't do this dot mutable. So let me go ahead and bring in the extensions using blog maui dot extensions. So this is it finding the? I don't think it's finding the extension method or the extension. Yep. Go back to my extensions. It's static. It's this parameter. Let's see, deleted. Yeah, it's not finding that either. That's, oh, okay. Yeah, it's not going to find that extension method because this is not IQueryable. This is a T predecessor. And so, if I were to make this an extension on T predecessor, now it's no longer select many, it's just like so. Whoops. So that's going to be, we'll just call it predecessor. That's right. So that's what I would like to work, but this isn't going to work. And I will show you why. So if we could get that to work, then it could be this dot mutable. And then I could say from site name, go back to name.site, and then from site name next, go back to next.prior. So I want that. And okay, that's not going to work because of this. This should be an enumerable of T successor. So now T prior is a collection of T successors. There we go. Now it's got that. And okay, so we've got it to compile, but the problem is we no longer have IQueryable in, IQueryable out, which means that that a LINQ query provider can't accumulate all of this stuff and give that back to the parser. So when I build it, it's going to build. The syntax is good. When I run it, that is where it's going to throw an exception. So let's give it a run and see the exceptions fly. And boom. Okay.
Yep.
So the exception see if we can see any details about it. Yeah, it's not giving me useful details, which is unfortunate. I really like my exceptions to tell me what happened. It's just saying it's being thrown by a target of an. Yeah, so we've got an inner exception. That is not showing me that inner exception. Let's, yeah, that stack trace is deep inside of the runtime. Yeah, we're doing system reflection. Okay. Well, the thing that it just tried to do, you can see this dynamic invoke right here. That font is really small, and I don't think I can increase it.
But it's visible.
Okay. What it has just done, because it found a function that it doesn't know what to do with, and that function returns an IQueryable, it said, okay, let me go ahead and compile that function so that I can call it. And this dynamic invoke is calling the compiled function. And once it compiled it, then that's where it did the run, and we ended up with something like this. So this dot mutable that calls this, we say predecessor dot successors. So it called into this function right here. Okay, that's not the one, and it returned a successor query. Well, that's good. But then the next thing that it did was of type. This is the one. Not implemented exception. So, yeah, this is where I should add a little bit more color. Now, unfortunately, that exception message not implemented didn't make it through. So I can probably catch the method call exception, unwrap the inner, and rethrow that. But yeah, ultimately, what I want to do is get the information back to the developer that, nope, you cannot call successors of type from your code. You have to build an expression tree that uses that, and then the query parser will be able to understand what you mean. So, still some work to do there. But that means that this particular variation of mutable is not going to work. I need one that takes an IQueryable. And once I've done that, that means you've already done the successors of type. With the predecessor selection, all I'm doing is adding the prior selector with a where no and just renaming that mutable. That's not very useful. So yeah, I don't think that mutable properties are going to get an extension method. Deleted not restored, that's a good one. Yeah, that one reads pretty well. Yeah, and see, you've already done the successors of type outside of deleted not restored, so that gave you your IQueryable to start with. So yeah, you essentially always need to do that.
Actually, now that you see immediately deleted not restored, automatically in your head you have the pattern. So it helps to visualize the code.
Yeah.
And that would be for the mutable property also, but
yeah. Yeah. With the mutable property, the best that we could get would be this dot successors of type site name dot site, and then we could do an extension here. So we can do this part, and in fact, in order to make that work, this would be IQueryable of t predecessor. Now we'll call that source again. And we don't have the predecessor selector. We just have the prior selector. And this is just source where no prior selector. Is that right? Yeah. Okay, can't infer it. So that should be t predecessor, t successor. Yeah, and now it doesn't fit. Oh, okay, because I've got a queryable of, yeah, so that's got to be this. I don't even have t predecessor anymore, so that, yeah, and now that can be inferred, so let's simplify the name. Okay, so yeah, basically what's just happened here is that mutable encapsulates the fact that the the prior selector operates on the same type as the thing itself, the successor. It returns the same type, and it encapsulates the fact that it returns a non-enumerable of that type. So it constrains your use a little bit, which means that we don't need this. I don't know. It's adding a little bit of value. And so it's that versus the where no. Yeah, if we were to do where no, then comment that out, then we would have to specify that this is site name. So these two things are equivalent. So adding a little bit of value.
The mutable is still nicer because it tells you really what you're doing.
That's true. Yeah.
It tells you what your intent is.
Yeah.
While the where no is mathematics.
That's true. Yep, and that is the whole point of these patterns, is to express the intent. So, okay, yeah, maybe we'll keep that one. So, yeah, I think I want to go ahead and ship these. Ship these extensions, so that you don't have to learn them, and you don't have to learn how to write them. And then I can teach people the patterns, and then start to open it up and say, this is what this pattern means under the covers, because then when you get to actually building an application, you're not always using these patterns. You're not always defining entities. Sometimes you now get into workflows, and that's a different set of patterns. Yeah, but yeah, as you can see, that is working. We've got our sites and our names. Okay. Well, that is what I've been spending far too much time on, and it looks like not entirely finished yet. So,
nothing is never finished. Wait, nothing is never 2 times no. No, yeah, not gonna think about that.
Yeah.
Next week, you were
Yeah.
not there, Michael?
Correct. Yeah. Next week I'm out. And then the week after, I should be able to show you Purge.
Okay.
So that will be awesome.
Okay then. Then have a busy week ahead.
Indeed. Yeah, it's
And
a vacation. I should be spending some time just relaxing, enjoying. Well, this is what I do for relaxation, so yeah, it'll be fun.
okay, it's holiday.
Yes.
Yeah, you're always a little bit with the daylight, with the daylight saving. We're
Mm-hmm.
a little bit later, and with the holiday, you're also later.
Yeah.
Yeah, school holiday is over. Uh, I think so.
Yeah.
Uh, since the children are out of house, I'm,
Yeah.
I have difficulties to know when is it holiday, when is it not holiday.
Mm-hmm.
Uh,
Yeah. It's been a while since I've had a child in school. So.
mm. No, but last weekend my daughter was here,
Mm-hmm.
so that means it must have been holiday.
Ah. Yes.
So
Very
okay,
good.
Michael, see you in 2 weeks then.
Yes, indeed. See you
And
then.
that's the same starting time as today then.
Yes, that's correct. Yeah, we're at
Okay.
1400 now for the next 6 months.
Yeah, because it's a little bit funny. So we changed for 1 week because our daylight saving is not at the same week.
Mm-hmm.
Then we go back or back synchronized. Okay. Perhaps it's the last time that they do that.
Yep. Yep. I am holding my breath.
Okay. See you, Michael.
All
Bye
right. See you
bye.
again. Bye.